EPA and MDEQ regulations, the MCLs or maximum contaminant levels, and they did meet all of those for the drinking water. However, for the brewery, there are certain chemicals and compounds that need to be at certain concentrations for optimal brewing. So as you can see, these are the current concentrations coming from the ELMWSA, and these are the target concentrations we're looking for brewed beer. And we chose these chemicals and compounds based on they tended to be the most important in the brewing process and had the most direct effect on brewed beer. So because these three were outside of the current concentrations, treatment would be required for the water part of the brewing. So the considerations for the design of the initial water treatment prior to usage in the brewery, the chloramine concentration was too high, the calcium concentration was too low, and the pH was also too high. So we needed to design a system to address all of those issues. So for the chloramine removal, we assessed a few alternatives. Some of those were the use of ultraviolet light, the addition of certain chemicals such as potassium metachloride, which is commonly used, and then a catalytic carbon filter. And after analysis, we found that the catalytic carbon filter would be the most effective. It takes the least amount of time to remove chloramine down to levels to which we need it, and it's also a pretty space-effective and cost-effective alternative. And then for increasing the calcium concentration, we assessed a few different calcium compounds, including calcium sulfate, calcium chloride, and calcium carbonate. We decided to go with calcium sulfate because the sulfate concentration was also quite low, or on the lower end of the spectrum, and higher sulfate concentration helps to bring out kind of the bitterness and the hops within the brewing process. So that makes for a good IPA. So we decided to go with the addition of anhydrous calcium sulfate. Finally, for the pH adjustment, we decided to go with phosphoric acid because that is pretty much the most commonly used form of pH adjustment in most brewing processes. This is just a brief summary flow chart of the operation. You see the water goes through the catalytic carbon filter. Chemicals are added via dosing pump into the utilization storage basin, where they then move on to the pond lake brewing company. So after this brewing process, we've got the brewery's wastewater, and we had a couple options for this. We could technically just dump the water down the drain and pay a pretty massive surcharge to the Sanitary wastewater treatment plant, but this just wasn't economically feasible or sustainable by any means. So we decided to go with the pre-treatment plant. And as you can see, these are kind of the typical brewery wastewater concentrations for biochemical oxygen demand, chemical oxygen demand, nitrogen, phosphorus, pH, or total suspended solids. And these are the requirements from the Sanitary wastewater treatment plant. So as you can see, the wastewater concentrations are pretty significantly higher than those required to be sent to the sanitary sewer system and ultimately to the wastewater treatment plant. So the pre-treatment of the water would be required. So we went ahead and kind of broke it up into a couple operations for treating the water. Initially, we went through a physical treatment process where we used 2 screens in succession, using both mechanically cleaning drum screens using a continuous belt system. The first screen is a fine screen, 4 millimeter opening. The second is a very fine screen of about 0.5 millimeter opening. This is just a diagram of the flow channels. As you can see, there are 2 channels in case one of these screens becomes clogged and causes significant head loss, in which case one of these slide gates will move over and allow the water to go through the other channel to just keep the operation going. The next step is the biological treatment, where we use microorganisms to essentially digest the phosphorus, BOD, and COD to remove those from the water and bring those concentrations down to appropriate levels. So we kind of choose between the aerobic and anaerobic processes for doing so. We decided to go with the anaerobic process because it is It's going to be more cost effective when you implement it on a smaller scale. It tends to be a much quicker process. And also it produces biogas, which is roughly 75% methane, 25% carbon dioxide. And we plan on using this biogas and methane to power the anaerobic digesters operations. So we decided to go with continuous storage tank reactor, or CSTR. Following that, we use thermophilic anaerobic microorganisms, which operate at a higher heat, and this helps the whole digestion process to happen much quicker. So we're going to keep the tank at about 55 degrees Celsius. Following that, the waste is then sent to a secondary settling unit where the sludge and suspended solids are then sedimented out and then taken to a storage tank where they're temporarily stored until an outside waste disposal company removes and disposes of that. And then finally we have the wastewater, which at that point will meet the regulations that will be sent to the wastewater treatment plant and can be discharged into the sanitary sewer system. So this is just a brief summary for the chart of that. We do have a lift station at the very beginning of the process to account for the head loss from the screening process. As you can see, it just moves through the equalization basin into the anaerobic digester. The biogases are then used to power the anaerobic digester, so it both heats and operates the stirring mechanism for that. And then the effluent goes into the settling unit, where the sludge is then contained prior to disposal, and the pre-treated water is then sent to the sanitary sewer system and ultimately the recycling wastewater treatment plant. So these are the predicted concentrations for the final wastewater after pre-treatment. So as you can see, these are all going to meet the regulations set by the Sanitary wastewater treatment plant and will be fine to discharge in that system without having to pay any surcharges or having problems with that. So finally, we're going to go through the sanitary sewer design. We decided to implement or utilize the existing sanitary sewer system that is currently in place. These red pipes are all 8-inch sanitary sewer lines, and those are currently existing. And those are more than sufficient to handle the flow from each of the structures, the restaurant, and then brewery sends its wastewater to the pre-treatment plant, and then that goes into the sanitary sewer line. And there were a few design restraints we had. It's a gravity-fed system. We decided to go with the 8-inch pipe because, I mean, most sources we're looking at recommended the 8-inch pipe. There is a 6-inch minimum, but to account for possible further growth, we decided to go with the 8 because replacing these pipes to accommodate a higher flow of wastewater would be very costly, having to excavate much of the parking lot. So, as you can see in blue, these are proposed 8-inch pipes that we're going to install. Those are going to have a grade of about 0.4%, and then the flow will vary based on times of the day, but they will be kept between 2 feet per second and 10 feet per second. At 2 feet per second, this minimum is set to keep material from depositing in the pipes, causing backups and clogs, and then the 10 feet per second is the maximum. Whenever that could cause scouring and degradation of pipe material. So yeah, after finishing that, we were looking at about 1,100 feet of 8-inch sanitary sewer pipe. And next, we are going to bring it to our water resources specialist, Rachel Norman.
Thank you, Joe. I'm Rachel Norman, and I'll be going over the water resources portion of the site development. So first, I'll be going over the scope of the water resources, followed by the permits, and then I will go into the design of the storm sewer system and basin, and then I will end up with some low-impact development alternatives for the site. So the scope of the work is to evaluate the existing stormwater management system, and then from there to design a new storm sewer system and basin for the site. These designs must be efficient and effective and capable of being permitted. Our final objective was to implement low-impact development when feasible on site. So for the permits, we will need a soil erosion and sediment control permit. And then with the National Pollutant Discharge Elimination System permit, that is obtained by the county, and we will simply need a notice of coverage in order to be included within their permit. And then finally, we have the tap-in permits that we may tap into their storm sewer system. The storm sewer system is designed using a 10-year, 15-minute design storm. The pipes that we are using are constructed out of reinforced concrete. For low impact development, we did incorporate a swale on the western side of the side, and swales are just large grassed channels that will open flow route the stormwater. For the pipe design, the diameters range from 12 to 30 inches, the slopes of 0.4 to 0.7%, and then the velocities are from 3.3 to 6 feet per second. For the Ingham County Drain Commissioner rules, the velocities must be between 3 and 10 feet per second. Under 3, there will be sedimentation in the pipes, in which there will have to be a more rigorous maintenance schedule, and anything over 10 feet per second, there will be scouring, and the pipes may need to be replaced more often. So this is the proposed storm sewer system. You can see that the red boxes, those are just conceptual subcatchments, so that the rainfall that flows into these areas will then be routed via the grading that's selected for the site to the inlets of the sewer system network. So we have 3 networks on site. There's one along the eastern and southern side going to the detention basin, one through the center, and then this system over here in the northwest corner will be feeding over to the swale that we have. So the detention basin will be have 3 inlets and 1 outlet, which I will be discussing later. For the detention basins, there are 3 design storm events that we have to factor in for. There is the 100-year 24-hour storm, and that is going to have the largest capacity. So that is the determining factor for the basin's minimum storage requirement. The second design storm is the bank full flood, which is a 2-year 24-hour storm event. And the major design constraint with that storm is that the water must flow out of the basin between 24 and 48 hours. Finally, there's the the first flush volume. This is the first half-inch of rain that falls on site, and this runoff tends to be pick up a lot more of the pollutants and sediments and everything on site. So that must be detained for greater than 24 hours or as a permanent pool, which is what we will be implementing on site. Finally, the maximum discharge from the basin may not exceed 2.2 cubic feet per second. The Ingham County Drain Commissioner requires that outflow may not exceed 0.15 cubic feet per second per acre of site that is feeding into the basin. There is an existing basin on site, and so we will be reusing as much of it as possible in order to save on cost and expenses. However, we will be needing to regrade it as the slopes are not the required 1 to 4, as required by the Ingham County Drain Commission, and we also will need to be expanding it. So for the 2 design storms, the 100-year and the 2-year, inflow hydrographs were produced and then routed through the detention basin using the pulse method in order to get design characteristics for the basin and the outflow. So this is the 2-year hydrograph. You can see that the peak inflow is about 8 cubic feet per second, and after routing it through the basin, the new peak outflow is 1.4 cubic feet per second. It is also important to note that at approximately 45 hours, the outflow is approximately 0, meaning that the storm has drained within the required 24 to 48 hours. This is the 100-year design storm hydrograph. The peak is much higher at about 17.5 cubic feet per second, and the new peak is at 2 feet per second, which is below the required 2.2 cubic feet per second. This is just a summary table for the detention basin. For each of the design events, it includes the volume, waterhead elevation, outflow rate, and drainage time. For the first flush volume, the volume is approximately 23,000 cubic feet. For the 2-year design storm, it's 103,000 cubic feet. And for the 100-year storm, it's 184,000 cubic feet. So that is the minimum required storage capacity of the basin, the 184,000 cubic feet. On this figure right here, you can just see the elevation change for each of the design storms based on the selected basin design with a slope of 1.24. So this is the outlet design. We will be using most of the existing network, which includes just several pipes, which then flow to an open ditch system, which then will flow to the Pine Lake outlet. Over here, we just have a cross-section of the outlet system. Notice we will be replacing the old pipe with a new pipe. The new outlet pipe is above the first flush volume because that's what we will be retaining as a permanent pool. So actually, the detention basin acts as a detention / first volume basin. We also incorporated a riser pipe so that if the water elevation does reach a certain elevation where there is a risk of the basin flooding in the area overflowing, water flowing over, it will instead go into the riser pipe, which will then be sent off-site. For low-impact development alternatives, we did incorporate a swale on the western side of the site. Another alternative that we would like to implement is a cistern. This is essentially just a large rain barrel that will collect runoff from the roofs. This water can then be stored and used for non-potable purposes, such as watering the green space, rain gardens, the rain islands, etc. And then there's also potential to incorporate a green roof or a blue roof on site. That is provided that the buildings are structurally designed to hold this extra stress. Blue roofs, they will improve the water quality as well as reduce the runoff that is going into the basin. And then blue roofs act to temporarily cool or pond the water and more gradually release it. This would decrease the peak of the inflow hydrographs and spread the flow over a more extended period of time. And without further ado, we will go into structures with Craig.
I'm Drake Weidenheimer. I was tasked with the structural design of the apartment buildings. Here's a brief overview of what I'm going to be talking about: scope, structural layout, structural parking layout, structural analysis, and final recommendations. The main task was to carry out a structural analysis adequately choose design for 4-story apartment buildings with underground parking. As you can see here, we went with 2 buildings, 2 apartment buildings. Structure 2 has the first floor parking, and structure 1 has the first floor retail, and both have the underground parking. Here you can see the structural plan view. This is a bird's eye view of the structural skeleton of the building, excluding the roof. These lines are all beams, and at each intersection is where a column will be placed. You can see the main beam length running east to west is 25 foot with 30 on the exteriors, and north-south direction they're at 30 feet. We decided to go with a steel building for this use, and we will be applying a spray fire retardant material to our members. Here's a structural elevation layout. You can see we have a truss roof to handle Michigan snow loads. We utilize chevron bracing to account for wind loads. The first floors of each building are 15 feet, followed by 12-foot floors for the residential floors. Here's our floor slab design. We will be using steel decking with a 4-inch lightweight concrete slab on deck, and we have shear studs to help transfer the load into the beams. And we went with steel decking over straight concrete for sustainability and increased strength. Here you can see the architectural layout. These are the residential plans for floors 2 through 4. We have bedrooms. We have units ranging from 1 bedroom all the way up to 4 bedrooms on the corner. All bedrooms have windows or window access. There are 2 elevators. There are 2 staircases, and as you notice, the columns are placed within the walls of the building, except for these 2. Those will be hidden in a closet. This is structure 1's first floor retail layout. We decided to put a grocery store on the right side and 6 retail spaces available on the left side. There's a central walkway that you can take from the parking lot all the way to the exit road and sidewalk. The elevators and stairs on this level, as well as the basement, will have resident key card access for safety purposes. Here are the structural parking layouts. These 2 are the basement parking garages. They're connected right here with a one-way tunnel. Each garage has a ADA handicap spot located next to the elevator. The underground parking unit garages will have 33 spaces each, and the first floor parking of structure 2 will have 36 spaces, totaling 102 spaces. Here's a parking flow of these structures. As you can see, we're coming from the parking lot, and the red arrow goes down into the basement level, and
comes out over here, up and down ramps, and the blue arrows indicate structure 1's first floor parking entrance and exit. The structural analysis was the main piece of my part of the project. As I said before, we chose steel. Material selection was the first part. We chose steel over concrete for its high strength per unit weight, its ductility, uniformity, speed of construction. Next, after I chose the layout, I calculated the loads that would be placed on the building using the ANSI minimum design loads for buildings and other structures. Some of these loads we had to account for dead loads, live loads, roof loads, snow loads, and a wind load of 10 psf on all vertical faces. Once I calculated the loads, I built a model on SAP 2000 computer software. This allowed me to run my load calculations onto the model, and it spit out a number of design forces in different combinations. And load combinations that governed for this design were load combinations 2 and 3. After that, I chose the shapes of our members. I chose W shapes for columns and beams and bracing members and truss members. I went with double angle. And once I pick the shapes, I take the maximum design forces and look up the values in the steel construction manual and pick my members accordingly. Here's a diagram of the two shapes I picked. Again, W shapes for columns and beams, and double angle sections for bracing members and truss members. And here are a few of the sections I chose to break down the typical members that I selected for our building. All connections weren't designed. It wasn't in my scope, but they would be bolted connections. And next, I have presentation.
Thank you, Drake. Like Drake said, I'm Lindsay Pedersen, and I'm your transportation specialist. So what we'll be reviewing today is our parking throughout our site, the site circulation, walkable community considerations, trip generation and vehicle trips, and then the intersection analysis of the Hazlitt Road and Marsh Road signalized intersection. For parking, according to the Meridian Township Parking Ordinance, we have a required calculated 656 required parking spaces throughout our site, but we have incorporated a total of 662 spaces, and this is to allow for electric car charging stations, as well as snow removal and placement for the wintertime. Types of parking, we have designated parking for the apartment in the brewery and wastewater treatment plant, and then shared parking. And we followed the ADA design guide to place the ADA parking spaces and calculate how many we needed. Those are located at the fronts of all the establishments. For the parking for the apartment, we have a required 300 spaces for the 120 dwelling units. 99 of these spaces are located on the structure parking shown by our structural specialist. And there's 102 spaces and then 99 not including the ADA spaces. The additional 201 parking spaces are located on the outside parking lot, and all of our parking specifications follow the Urban Land Institute specifications as well. And it should be noted, we go back to a second, for the apartments that we're going to have all permitted parking, so that way for the structure and also in the parking lot that it's easy to just find the spot that you are designated for, as well as the visitor parking. There'll be a visitor parking lot as well. For the brewery and wastewater treatment plant, we have a total of 47 required parking spaces that are outlined in red. And those are for employee and visitor parking. Visitor parking will mainly be used for brewery tours at the brewery, and then those will be designated with signs too as well at those sites. The rest of the parking on site is shared parking outlined in the site here. And there's a total of about 315 spots that are shared between the grocery store, the retail, the restaurant, and then the dog park. So site circulation, the primary path of travel throughout the site is along the perimeter. We have a roadway, and there's also easy access for the southern portion of the site with a one-way drive here, so that way that a car does not have to travel the entire length of the site to get to the southern area. And this will be properly signed, so that way people know that there will be a no left turn on the westbound movement because of the turning radius. There will be a stop sign before entering the southern part of the site, and then there will also be a do not enter sign for people that are already located on this road. And then for secondary paths of travel, that would be throughout the parking lot and then in front of the storefronts. And then there will be stop signs in front of all store entrances to accommodate for pedestrians. So for the driveways, we have a total of 3 driveways on site. Currently existing, there are 4 driveways. There are 3 on Hazlitt and then 1 on Marsh Road. We have eliminated the middle drive on Marsh Road that was located here to accommodate for the structures that are being placed. So the 2 driveways that are on Hazlitt Road, we have the west driveway has an inlet and an outlet, and the outlet has separate lanes for the left and right turns. The eastbound driveway on Hazlitt Road, or the east side driveway on Hazlitt Road, has just an outlet, so it's an exit only, and there are separate lanes for the left and right turns. Our Marsh Road entrance and exit is shared lanes for the left and right turns for the outlet, and then 1 lane also for the entrance. Walkable community aspects, we have sidewalks that run the entire perimeter of the site, as well in front of all storefronts, apartment building, the brewery, wastewater treatment plant, and we have crosswalks anywhere that the sidewalk is separated by the roadway, as well as being able to accommodate for easy access throughout the southern area of the site. And the central hub has sidewalks surrounded by it too, and as Matt had kind of mentioned, that does connect to the southern parking area, or the southern lot of the site, that has the dog park, the off-road corridors, and then the inter-urban pathway. And these corridors are meant to be a shared use path, so that way you can use it for rollerblading, for walking, for strollers, for bicycles, skateboarding, whatever you may wish. Trip generation was calculated using the trip generation software, and this incorporated the different establishments that we have on site along with the gross floor area to determine the number of entering and exiting trips for the AM and PM. It should be noted that our first floor retail, that we have 6 on site, and we just used a variety of different land uses to accommodate for a diverse representation of who might possibly run off that site. So as you can see, there's a total of about 710 between entry and exiting trips in the AM, and a total of 555 approximately for entry and exiting for the PM. Pass-by trips and internal capture were also calculated. Pass-by trips was calculated by the trip generation software as well. There were only 2 establishments on site that were in consideration for pass-by trips, and that was a grocery store and then one of our 6 retail options. And this is just to accommodate for people that might come in, they might stop to grab a coffee, stop to get gas, stop to drop off a movie, do a quick stop such as that, and then continue on to their ultimate destination. So for the AM, it was calculated to have a 0% pass-by trip, and then for the PM, it's approximately 35 to 45% for pass-by trips. Internal capture was estimated using the ITE trip generation estimation tool, and that was done in order to determine if there's a car that comes on site that is making multiple trips, so maybe to stop for coffee and then go to the restaurant and then go home to their apartment at the apartment complex, that would be only considered 1 trip instead of 3 separate trips. So that was calculated for the AM and the PM. For AM, there was an estimated 0%, and for the PM, we have a 23% internal capture. And for the PM, this really goes to show that during the PM peak hour, the parking lot is not going to be at capacity, and that there will not be people driving around for extended periods of time trying to find a parking spot. An intersection analysis was done on the Marsh and Hazlitt intersection that is currently there for both the AM and the PM. As you can see on the left side of the screen, we have traffic volumes and proposed turning movements for that intersection, and we have left, through, and right movements for all the different approaches. And then on the right side, we have a chart that describes the different measures of effectiveness that are proposed for this site. And this was done using Synchro 6 analysis, and we took the existing traffic counts that we have 2014 data from the Ingham County Road Department for the intersection, and then the driveway was done using just the traffic counter in order to calculate current driveway. And we did distribution depending on which way the cars were turning out of the driveways, if they were turning into the intersection, and then which driveways were utilized how much. So as you can see for the PM, the only real change in the measures of effectiveness were the level of service for the westbound approach, and that went from a C to a D. All other ones were not increased very much for measures of effectiveness, and this shows that the Marsh and Hazlitt intersection for the AM will be able to withstand the traffic that will be generated by the proposed site. This was also done for the PM. So again, we have the turning movements on the left side and another graph on the right side. The same westbound movement was also affected equally the same, so it went from a C to a D as well for the level of service. And being able to optimize those cycle lengths and those split times, we're able to actually make some of those measures of effectiveness better. So we went from an E to a D on the eastbound. Some of the delays were decreased, as well as the intersection delay was decreased. So this also shows that for the PM, we will be able to as well have that intersection be able to withstand the traffic that is generated by the proposed site. And next we have payments with Andrea. Thank you.
I'm Andrea. I was in charge of all payments on site, and I'm just going to take you through a quick
walkthrough of how pavement analysis was performed. So to start off, I'm going to go through the existing pavement condition currently on site, then look at some different design alternatives, do a life cycle cost analysis to determine final recommendations. So initially, Hazlet Village Square was visited in January, and as you can see, the current parking lot on site is 90% covered in distresses from just the environment. Because of this, it was given a present serviceability index, which is just a measure of ride quality of 1.5. The existing Hazlet Road was currently redone in 2012, so it's still in very good condition and was given a PSI of 4.8. For existing Marsh Road, there are existing longitudinal and transverse cracking, and because of this, it's given a PSI of 3.5. So the equivalent single axial loads were used to determine just different easels on site, and this was done using Union County Road Commission's traffic counts provided by our transportation specialist, Lindsay. Also, the MDOT values were used in this equation to get the 1-year easel. This was then multiplied by the growth factor to design for a 20-year design life, and values found are shown here for both flexible and rigid pavements. So different design alternatives were considered for each road individually based on the current condition. So for Hazlet Road, since it was recently redone, it was considered just leaving it in the existing condition. And this was analyzed using the MEPDT software. The results from this determined that it would almost get to 20 years, but it would fail in the longitudinal cracking. Because of this, 2 other design alternatives were considered: a flexible overlay and just maintenance of crack sealing. For the flexible overlay, this was calculated using the ASHO 93 overlay design, and when this was done, it gave us an overlay of 0 inches, just because it's still in really good condition, so this was automatically discluded as an option for Hazlet Road. Therefore, the only thing left to analyze was the crack sealing. For Marsh Road, a rigid reconstruction was analyzed, which gave us the 8-inch slab. A mill and fill and a flexible overlay were also analyzed similarly, and this gave us 2 inches for both. So the cost per lane mile was the next step. For crack sealing, the MDOT maintenance standards were used as a base point of $3,800 per mile. For Marsh Road, both the mill and fill and the overlay were calculated using the same process. So it was the 2 inches determined using the design alternative multiplied by the length and width of each lane, which is 12 feet for Marsh Road. And then the rigid reconstruction needed to include the design slab, the subbase, the under drain, and also the removal of the existing asphalt layer. So this was, these values were a base for the life cycle cost analysis used as the initial rehabilitation. Also included were the user cost, maintenance, and traffic control. For user cost, because of some of the design alternatives we have, such as crack sealing, this was or was not included in the cost. For example, crack sealing can perform very quickly and efficiently, so it's not really going to cause any user delay. And then the traffic control and maintenance values were again taken off of that design manual. So this was used to determine the present worth and the EUAC, which is just the yearly amount you're losing. So for Marsh Road, it was clear that the rigid reconstruction was going to cost the most to perform, and that the overlay was going to be the most cost effective. So final recommendations, based on the life cycle cost analysis, Hazlet Road, of course, crack sealing, so there was nothing that really needed to be redone or reconstructed. For Marsh Road, it appeared as though the overlay would be the most cost effective, but when it was researched further, it would actually cost more based on the addition of the curb and gutter, and to raise it to the same level. Because of this, a mill and fill is recommended. So it's going to be milled off 2 inches, and then it's currently an existing 5-inch asphalt layer. So this will leave a 3-inch HMA existing. And then for the parking lot, it needs to be completely torn up and reconstructed. And so it can also be noted that the subbase material can be recycled and reused just to have a sustainability aspect. The off-road corridors, we really wanted to follow the Meridian Township Green Space Plan. So based on this, they wanted to have a 3-inch asphalt layer with a 5-inch crushed aggregate base. And for this aggregate base, we want to use the HMA layer that we're ripping up in the parking lot and also on
Marsh Road and use it as the 5-inch crushed aggregate base just to recycle and to not have to increase costs for new material. So to maintain traffic while all this construction is going on, Hazlitt does not require any detours. It can be performed very quickly, so there's no maintaining traffic requirements for that. For Marsh Road, the construction will take up 2 lanes at a time. So 1 lane will be milled and filled at each time. So closing 2 lanes, and then there are still 3 lanes available for detouring traffic. And now I'll hand it off to Matt to talk about cost testing.
Thank you, Andrea, and thank you, team. So we finally come down to the proposed construction schedule. If you notice that we are proposing a very aggressive construction schedule of 13 months, which we plan on beginning January 2016 and ending in February 2017. And our final cost analysis was performed for the entire project, including all the sub-disciplines. We'd like to again point out the geotechnical design work was not included within this cost analysis, and also this cost analysis encompasses only our scope of the project that would be covered. So as you see, we have the environmental, wastewater, structures, pavement disciplines, and then we, at the end, incorporated a 10% engineering fee and also a 15% unforeseen cost fee, which gave us an estimated project scope total of around $6.9 million. So in summary, our objective from Capstone Collegiate Investors was to create a development, preliminary engineering development that incorporated the mixed-use design, including a residential building, which we elected for 2, a new grocery store, a restaurant, and a brewery on site. Thank you, and now we have our question and answers.
Very good job. I'm Phil Vogelstein with AECOM in Grand Rapids, Michigan, and I'm the hydraulics and hydrology specialist, so I'll ask a few questions about that. In the detention pond, we've mentioned you're going with a permanent pool. You might look at slide 41 or 42, somewhere around there, I think it was. You mentioned that is the plan, to have a permanent pool for the first flush.
Yes.
How's it going to be permanent? How do you make it permanent?
Well, the drainage outlet pipe is just above the elevation.
Okay.
That is from the volume of the first flush, and I got this design from the MDOT Drainage Manual, Chapter 8. That permanent pool will remain there. It may go into a little bit of infiltration processes, but for the most part it will remain. It won't be.
When you hire that geotechnical engineer,
Yes.
make that a point of discussion, but you don't. Okay, so let's assume that we do have some water there. I think you showed that on the next slide, the permanent pool. Yeah, there it is. So if that's to scale, we're looking at what, a couple of feet, 2-3 feet?
The new outlet pipe is about 1.25 feet above the base elevation.
Okay, so you're going to have a couple of feet or less of water.
Yes,
there.
it's going to be no more. I think when I actually calculate it out, it's just a little bit over.
Okay, so your safety feature's fine.
Yes.
You're not going to have too many people drowning there. That's good. Let's see, even if somebody drives a car into it, they're likely to be okay. You're going to have trouble with photosynthesis. 2 feet of water is not enough to stop growth on the bottom of the surface. So something's going to grow.
Yes. We'll be certainly implementing a maintenance program for the basin. So.
And you'll also have recurring problems with mosquitoes, except that you're going to deal with that with
Maintenance.
Very good, very good.
We thought of everything.
Okay. You don't have any trouble with the water table there as far as keeping it dry? Keeping it down to that level?
No, that is actually the base elevation that we're using is the one that is already currently used for the basin.
Okay.
Like, yeah, so the existing basin already has a base elevation of the 846 feet.
Okay. More general question. There's already a bank at the corner of Marsh Road and Hazlitt Road. My recollection is it's fairly new. Do you have a rationale for taking that out and replacing it with a restaurant?
Yes, thank you. That's a very good question and concern. At the beginning of our project, we were really toying around with the notion of stripping the existing site of all of the buildings to be able to facilitate our proposed design. So in order to implement what the township wanted, what the scope of the project was, we felt it necessary to remove all the buildings and to start basically from scratch and then create more of a future sustainability site that we'll be able to utilize. Because currently, as I mentioned before, the property is underutilized. So from that perspective, it's more of an eyesore right now. I'm not going to say it's an eyesore. You could be argued to be an eyesore. I don't want to offend anybody, but so and that's why we were approaching this redevelopment.
A minor question. I've heard this a couple of times. Permanent parking. What is permanent parking?
So for permanent parking, that's referring to each resident, depending on their dwelling unit, is going to have a number, and that number will designate with a parking number that will be on that spot.
Oh, so it says assigned parking.
It's assigned parking, yes,
Okay.
sorry.
I thought it was like not biodegradable.
Yeah.
I'm going to assume someone else is going to ask about wetlands impact, so I'll pass this on now. Thank you very much.
Michael Phelan, I'm with Consumers Energy and Geotech, so I don't have a home. I'm for hire. I'll ask a couple of questions. First, I want to make a statement. Your presentation was the most polished, best quality I saw.
Thank you. The team worked really hard. We were practicing a lot.
Yeah, great job. I'm going to ask a couple of questions out of my area of expertise. Environmental, what is the surcharge cost, or what's the cost to directly get your water, wastewater to East Lansing? Is that per day? Or?
It's more per 10,000 gallon charge.
But annually, what? I mean, I'm just, if I were building a brewery, I would probably think really hard about all the capital costs and maintenance costs of wastewater treatment plants. So I'm just curious what that equates to annually.
Off the top of my head, I couldn't give you an exact number, but it was closing in on about $1 million or more per year with the amount of UV and COD in the water, because it's based on concentrations, which in some cases were tenfold what was recommended in one case.
Yeah, because if I were developing my full form line, pavements, quickly recycling or reusing the sub-base. Do you know you can? Do you have quality information on that?
I don't have quality information on that, but based off what I read, just